Hello and welcome to another lecture. We're going to continue with the lecture number 2 for static. This time we're going to talk about what is force and what is versus load. Force and load, they basically did the same thing, but in the kindergarten of engineering, which is this course, static, we're going to start out with a force and then understand it, how they work, what it is anyway, and how we use them. So let's go to the PowerPoint and show you what's going on here. All right, in this lecture, we're going to learn about define and explain the four fundamental quality of force. So we're going to talk about force. That's all it is, the whole lecture is. And talk about the unit of the force and their multiple, and both in U.S. Imperial system and SI system. Then we're going to talk about the different type of a force and load on the structure. Then we're going to explain the principle of the force and how they influence the body, and then we're going to do some analyzing work with it. And I hope you like these cakes. So when we look at something that you probably learn in physics is about the vector. Vector is you learn about scalar, which are quantity that are fully described like by themselves, like a temperature, mass, pressure, time, length. But vector are a little bit different. They have a shape like an arrow, has a tail, and has a head, and has a direction, and also has a magnitude, and has an angle to it. And that's a vector that we're going to use the same thing for defining a force. Hope you're hungry. This is for class. Anyway, criteria for force, there are four different criteria keep in mind. One is a magnitude. What is the magnitude of the force? 500 pound, 1 kip, 100 kilonewton. That's the magnitude. That's the amount based on the weight of the object or the force of the object. Then there's a direction, referred to the path of the line along which the force acts. It's which direction it is going. And basically what we call is a line of action. Is it vertically, horizontally, or what angle? Then there's something called sense, which kind of refers to the way in which a force acts along its line of action. And we get to those. And then we have a point of application where this force is applied, at which point. Anyway, and there's an example for it from here. And now, force versus load. Later on, when you go to higher classes, we're going to use load instead of force. And in engineering, a load is a specific type of a force exerted on a structure or a component. A lot of times when we design a beam column, we put a load on it. And a load, then hopefully the column and the beam that you design, the capacity of it is bigger than the load you're going to put on it. So where the load comes from, it's a huge class by itself, upper classes. And it's a force, basically. Force and load are the same thing. And in engineering. And to find out what type of a load, of course, I have done many videos on that. ASCE Chapter 2 has a really, the whole ASCE talks about load and the load combination. You're talking about earthquake load, seismic load, wind load, dead load, life load, all that, which you will learn that in the future. And if you're really interested, you can go watch some of my video. Then the unit of the load or force, in imperial system we use pound, could be 1,000 pound, 2,000 pound, or kip, which is a 1,000 pound. So 2,000 pound will be 2 kips. And in SI system, you got to be careful. I will do an example in a minute. In SI system is a Newton, which is basically the kilogram multiplied by 9.8 meter per second square, and they're converted to Newton. Let me show you something here. The other thing we got to look at this classification of the force system, maybe depending on how you look at it. You can say they're coplanar parallel to each other, as you can see here. Basically, all forces act in the same plane, and their line of action intersects. That's a coplanar concurrent, which is this one right here, and they all come into the same point. Then you have a coplanar parallel, which is kind of right here. It's all forces act in the same plane and their lines of action are parallel to each other. Kind of important when you take a moment about a point. And then you have a coplanar non-concurrent. That means you have a different direction. Some comes in the x direction, some comes in the y direction. And we see a lot of these in a future example also. One important thing that we're going to do from now on is the sign convention force. We're going to say FOI, forces in a y direction going up, is positive. Forces in the FX in the x direction going right is positive. And then later on we will talk about something called moment. And moment counterclockwise also is positive. So this is our positive sign that we're going to use from now on in this class. And what we're going to do in this lecture, we're going to focus on combining forces, resultant forces. For example, if you look at this tugboat right here, and this tugboat pushing this way, this tugboat pushing that way, and that's going to define where they want this barge to be going. Like here I have this example. It's push coming from this way, push coming from that way, and you can see you have a PX and PY, and the result will comes in an angle of 45 degrees, if assuming they both PX and PY are equal, and it comes in this direction. If you want to push the tug going this way, so that's how it comes out. So we're going to learn about this direction of the force or vector, which way it's going to go based on an angle of applied and where it's applied. And what we're going to use, like last week we talked about the sine and cosine and tangent law. That's what comes in handy. And the Pythagorean theorem. So now when we look at these forces, like here, you have a Py and Px, and you want to know where this angle of P comes in. We basically say P is equal square root of Px squared plus Py squared. And then the angle we're going to use tangent. Tangent always is what? Opposite divided by adjacent, and that's how we're going to find the angle. So we're going to do a bunch of examples like here. Actually, there's an example right here in front of me. So let's do this example. All right, let's do this example. So the first thing I want to do is establish the sign. This going right here, x is going to be this way, y is that positive. So if you're going up positive, going right is positive. Then we know minus 200 is that this is going to be minus 200 right here, and that's going to be plus 100. Another thing is where we like to find out the resultant of these two forces. And if you take square this vectors out, basically right here, and your resultant force should come out someplace right there. Perfect. And thus we're going to find the magnitude of that resultant force. This right here, we call this resultant force. And then we're going to find the direction of at what angle it's going to be. So let's work on that. The equation that we learned was we're going to say R is equal square root of minus 200 square plus 100 square, and that's equal 224. And the theta, so theta, which is right here, it's equal tangent inverse. Now opposite, which is basically 100, divided by 200. You don't have to put the sign convention here, just 100 divided by 200, the magnitude itself. And that's equal 26.6 degree. And this is the simplest as it really can get, but from here we can go ahead and do other example which is more complicated. All right, let's do this problem. This problem, we have this telephone pole right here, and you have this guide wire right here. The tension on this guide wire right there, it's about 300 pounds. And the angle between this guide wire and the telephone is about 42 degrees. Basically, we'd like to know what is the horizontal and vertical direction of the forces. Okay, so first we're going to find out f of x. Actually, let me switch screen. Okay, so this is our sine conversion, and this is f is equal to 300, that the wire has a 300 tension on it. If I want to find the f of x right here, f of x, remember, this is my force coming down here. If I close the gap, that will be cosine. If I open it up horizontally the other way, that will be sine. So remember that always. If I close the gap right here, that become cosine. And if I go the other way, it'd be sine. So it's going the other way, it's going to be sine. So it's going to be f of x, and that's going to be 300. Again, it's going this way, it's positive. So it's 300 sine 42. And that's equal $201. Okay, so it's 201. If I had to go ahead and make a corner right here, and that's going to be basically right here, 201. And f of y, it's going to be, again, it's coming down, it's negative, so minus 300 cosine 42. Again, if you close the gap, it's a cosine. And that's equal minus 223. So basically what I have, this become right here, minus 223. And if this were just like previous problem, you just gave me this and this, the resulting force would be just like that, coming down like that. And we can go backward and calculate that. So we did one when we had these two, and we figured this out. This time we had the resultant force, we figured out f of x, f of y. Let's do another problem. Just pick it up a little bit of notch, put some garlic and hot pepper into the soup, see how it comes out. Okay, so we have the block. It's on an inclined ground of 5%, and it's in a kilogram. Because it's an SI system, now what we got to do, we got to remember we talked about force. Force in imperial system is pound, in SI system is Newton, but the weight in SI system is kilogram, so we got to convert this kilogram to, it's a weight converted to a force. And the way we can do that is 400 kilogram, we know that, and if you multiply that by 9.81 meter per second squared, that will give us 3,924 Newton, or 3.924 kilonewton. Okay, so now we know the weight of the block is right here. It's vertical. It's the gravity is vertical. Okay, so that's the weight of the block coming down vertical right here. But because the ground is, it's on a ground of 5%, our f of x is going to be in this line right here, and our f of y is going to be down at the y. We shifted our x and y. No longer we using this x and y Cartesian. The ground shifted, so this is going to shift this way too, and that's, this way. So that's going to shift this way, and our y is in an angle of 5 degrees, same as with the x. Okay, and another thing, this is our positive. X positive to the right, y positive to the up. Moment we deal with later, but so this is where we are. Now we're going to find the f of x. So our f of x is equal Okay, to get a f of x, remember we talked about sine and cosine. This is my weight is right here, vertical. Okay, this is the vertical. This is the weight, the vertical coming down this way. This is the weight. So close the gap between that and x is a cosine. So that's going to be x to the right is positive. So it's going to be 3.924. And that's going to close it with a cosine. And the angle, because this is a 5 degree, so this will be also 5 degree right here. And 90 minus 5, that's going to be 85 degree. Okay, so we're going to say cosine 85. Kilonewton. And FOI, we can do this two different ways. Let me change color for good luck. So FOI, I can just go ahead and close the gap this way. Or because I use this one, I still can use that one. If I use cosine, I can use sine over there. So I'm going to say it's a negative. It's coming down negative, right? So it's going to be minus 3.924 sine 85, which is equal .91 kilonewton. Now, I could do the same thing. Say, okay, close the gap, make it cosine. That will also do. Cosine 5 degree. Bet you comes out to the same number. It should. So far, this week and this lecture, we're going to just learn about the interaction of the forces and their angle, how we can combine them, how we can separate them, and then that will get us ready for the next lecture, which is the week ahead. But let's work on this for a whole week. And if you like it, give it a thumbs up. Have a good day.